right, so
Yes.
we are continuing with this discussion. The discussion is around concentrated solar power and thermal innovation. Our three speakers were firstly Professor Craig McGregor and Prof. Willem Leroux, and then Yuri at the end. We heard that what they presented around concentrated solar, all the nice innovations from Pretoria University, and practical applications, and so on, described by Yuri. So let me start with Craig. So Craig, you're Craig because I always called you Craigs. We worked together at Sasol, as Craig has reminded me, quite some time ago. The first point I would like to sort of mention is if you talk about concentrated solar power, it's more like an industrial plant, if I can call it that, whereas PV is some panels and wires, and that's basically it. So the one thing that I've seen, Craig, and in the comparisons of CSP versus PV and batteries, that's, I think, always overlooked is the stability and the inertia of the grid. And some of the renewable projects that we are involved in, there's an additional element, which is what they sometimes call a synchronous condenser or something, which adds significant cost that I'm not sure that you covered that on your comparison. Maybe you can comment a bit on that for industrial use where you need this inertia. You're on mute, Craig.
Thank you, Friek. So thanks, Friek. Very good question. So in the comparison, I do not account for inertia, but with concentrating solar power with CSP, you get the inertia for free because you have a turbine, whereas you may have to add a synchronous condenser if you've got a PV plus battery system. So that's an additional cost or an additional benefit that you get from CSP. So no, that wasn't included in my comparison.
Yeah, I think that is one of the things that sort of overlooked and not really appreciated for the sort of industrial use. And I think Yuri asked the question here, why is CSP sort of seen as a bit of a stepchild as compared to normal PV and so on? I think there needs to be quite a bit more almost education of the differences.
So, Friek, I don't know if that was addressed to me, but I think there are, I think, a few important points in why CSP is kind of the stepchild. The first is PV you can apply anywhere, whereas CSP you need good beam or BNI. So not everywhere in the world can do CSP. We uniquely, but not uniquely positioned, but we're well positioned to do it. Not everybody can. So PV was going to expand faster than CSP just based on sorry. The other thing is that, as you say, CSP is more of an industrial energy technology, whereas PV panels you can put up on your home. So CSP is definitely more complicated. And then, as I said, for a long time, CSP and PV haven't been compared on apples with apples comparison. So that has also been kind of the thing that's held back the CSP industry.
Yeah, thanks, Craig. I'm going to stay with you a bit longer, so bear with me. The whole issue, and I think you mentioned it, this sort of 10 megawatt modular units that sort of Yuri and I discussed previously, and it could be sort of deployed at a factory and so on to supply the continuous load. It is modular. It can be able to roll out fairly quickly. You've enlightened me that you can't do this everywhere, but can you maybe expand a little bit more on this sort of opportunity?
So, the opportunity is basically anywhere in the country that has a DNI above about 2,000. So it excludes kind of the coastal areas on the eastern side of the country. So for me, you'll know that Durban's cloudy and has more rain. But any of the drier parts, from the Highveld west, you can use it. So it's very suitable for a large area of our industrial heartland through to the Western Cape. Particularly placed, if one of the advantages is if you're in one of the summer rainfall areas, is that you get really nice sun in winter. So you also get a good balance between the summer and winter solar resources. I think you had another question that I missed, but that was the one question.
Yeah, I think the other point is really, or two more questions for you. The one is, what opportunities are there for CSP to really become more cost effective? In my mind, it's a turbine and this and that. I'm not sure how you can really reduce the cost, and where are the main costs on the solar side or the heating side or whatever? What do you see happening to reduce it significantly?
So around half of the capital costs sit in the solar field. And that's where a lot of the research and development is happening. The Chinese have done a very good job of advancing that. Advanced manufacturing has been applied. You really need to apply the same kind of thinking that you do to the automotive industry, because for manufacturing the components of the solar field. So that fits nicely as well with South Africa's industry.
Thanks, Craig. Appreciate that very much. Prof. Willem, now I'm trying to think about questions to ask you. Oh, sorry, I must go back to Craig. There was a question about how long does it take to construct such a CSP plant?
So they have a longer construction time than PV plants. PV plants are typically a year. A CSP plant you can do in 2.5 years or so.
Okay, thanks very much. Okay,
but it will definitely differ, depend on the size of the installation.
Yeah.
I'm sure that the smaller installations that Willem was talking about can be constructed in perhaps half that time.
Yeah.
We're talking several months. Willem, if you'd like to comment on that.
Yes, sure. I can jump in here if it's fine. Of course, the smaller, the quicker it can be deployed and manufactured. So yes, I do agree. Of course, then you have a smaller setup.
Yeah.
But yes.
Yeah. I mean, Yuri, I'm now thinking again about this 10 megawatt modular thing. If those become like a standard modular unit, And linking on to Craig's point, then you can set up a manufacturing thing that can sort of roll these out fairly quickly, I guess. Yuri doesn't want to comment on my comment, on his comment.
Well, there's not much to add. Yes, I agree.
Prof Willem, so very, very interesting the things you are doing and so on. A lot of it, if I may say, is like research work and so on. How do you see this happening? Do you see these smaller units being able to be deployed in grids or mini grids and so on, and maybe a bit scaled up from what you are doing? Or what is your vision of how things could happen on the small scale?
Yes, absolutely. So I think every technology will find its place in the sun. You know,
That's a good way to comment.
So there might be a specific technology that's not going to fit in well for a household. It might fit in better in an industry. And there are many examples like this. So what we are focusing on specifically is micro CSP, and we've been looking at micro turbines. And yes, you're correct that we can deploy mini grids that is running on a micro turbine, and that micro turbine can then be supplemented from various sources. It can be gas, it can be concentrated solar power, it can be high temperature thermal storage. It can also be PV, even where PV can be used to charge these thermal storage units. I mean, we have a PhD student working on that currently, where you would have to make that decision in your mini grid as to what resources are available at the time and how you want to store and buffer the energy for future use. So absolutely that is one direction that this research can go into mini grids. I think microgrids would be a larger scale. Mini grid is actually smaller than that, and you can even use the term nanogrids, depending on your on where you are currently working, or what is currently the field that you're working in.
There's a little micro turbine, just out of interest. We are working on LNG liquefaction, where we use what we call a compander that has for our small plant, it has a diameter of 100 millimeters, the impeller. How big are these little turbines of yours?
Yes, it's more or less on the same scale, though. We're looking at smaller ones, so you could call our turbines nano turbines if you want. We're looking at 40 millimeters or so, if I remember correctly. But what we are considering to decrease costs is really to use technologies that are already available on the market. We're specifically looking at turbochargers, because a turbocharger is basically a micro turbine without a generator or motor connected to it. So that is something that we've been investigating. We are also seeing this development in the vehicle industry, where turbochargers are starting to actually come out with a generator or a motor already coupled to it, which means in future these devices might actually become cheaper and more available, so that we can plug them into mini grids.
Yeah, I think you must talk to a Ferrari or Maserati or to get some of their turbos.
Yes, exactly. But you know, these technologies have to start somewhere, and initially they're very expensive, but costs should come down. I mean, the same thing happened with PV. Initially, PV was very expensive, and the cost came down as
Yeah.
people were doing more research.
Yeah.
And I think the same is going to happen with CSP.
Yeah.
I hope so.
Now, you spark a lot of people's interest on melting of metals and all these sort of things. And I think we must talk a little bit about that. So Brendan Hausberger, a colleague of ours that we know quite well, he says, in terms of mineral processing work, what is the economic scalability or limits you foresee, especially considering, for example, galvanizing and the need to keep the kettle molten?
Yes, sure. So, of course, we can talk about different scales. What we are investigating is a nanoscale. We're talking about the informal recycling industry that where people are already melting aluminium to manufacture pots and so on. That's something that we realized when we visited the rural area. We saw that people are already melting aluminium cans and they are pouring the molten aluminium to cast certain parts and pots. Now, this can of course be upscaled, but it will have a limit. I mean, a solar dish can only become
Ice or Marina van Heerden.
Sorry.
sorry. So a solar dish can only become so big. It does have its limitations. It becomes a very big design challenge if solar dish is too big. And the next step after a solar dish is usually to go to a heliostat field, like what Craig is working on and what he showed. So we are interested in small scale solar dish, and I think to upscale that, one would have to go into a heliostat field. The upper limits of a solar dish, I've seen big solar dishes, but we haven't really built one larger than 7 or 8 meters in diameter.
Mhm. Excellent. Thank you very much, Willem. Selwyn Boyson, Yuri, maybe you can talk a bit more about that. When he said he joined a bit late, but what are the different temperature ranges and current realistic stuff for CSP or thermal systems? Maybe it's sort of a bit of a question for everybody, but maybe Yuri, you can start.
I can start. The limitations are in the heat transfer fluid that you typically use. If you use a heat transfer oil, that typically starts to deteriorate above 395 degrees Celsius, which means you have to run below that temperature if you use a heat transfer oil. If you use molten salts, you can probably go up to about 600 degrees, perhaps slightly more, depending on the salt you use for that purpose. But there are other systems. I mean, you can heat air directly, or you can heat CO2 directly, or the latest thinking is to heat up falling ceramic particles directly. And by using those systems, you can actually go up to 1,000 degrees Celsius.
Mm-hmm. Thanks. I think, Willem, you actually did mention some temperatures and the different type of collectors, if I can call it that, just now in your discussion. No, Craig, if you have any further comments on that.
Yeah, so as Yuri said, the research is targeting temperatures up to 1,000, but there are commercial applications at both the 400 and 600 degrees C limits that Yuri mentioned. But a lot of the industrial heating now that's actually being deployed internationally, particularly Spain, Italy, the sunny areas around the Mediterranean, they're just targeting around 200, 250 degrees C. So you don't have to be targeting those very high limits.
Okay, yes, excellent. Okay, thanks, Willem. So then another question for you is the practical limits around the temperatures and the applicability of the technology. Maybe you can just elaborate a bit on that.
Yes, I see the question was on the scalability, especially considering galvanization and the need to keep the kettle molten. So yes, what we are looking at is hybridization. So you have gas and concentrated solar that are both utilized to keep that kettle going. So yes, galvanization is one opportunity. The other is just manufacturing, metals processing, recycling, like I mentioned, with the aluminium cans. And I think there is a large opportunity on a smaller scale to utilize concentrated solar with or without hybridization with gas.
Okay, thank you very much. I think the hybridization is quite an important point also. Yuri has asked a question here, Craig, about stereo systems that you've developed, which we didn't address yet.
The stereo is a heliostat that was developed between South Africa and the Germans, and it's a pentagonal shaped heliostat, so it's not the normal rectangular. So if you look at my back through the talk, the one central receiver picture I showed, you can actually see the stereo heliostat in there. It's considered kind of the gold standard of heliostats in the world in terms of it has the lowest cost and best optical performance. So it's really a fantastic achievement in terms of what we achieved there. Unfortunately, it's not been built in South Africa, although it was developed to be manufactured here. It's actually the Chinese who've gone in and are deploying it, and they've put, I think, around 400 megawatts already of stereo heliostats into central receiver plants in China.
Oh, interesting, eh?
Are they building them under license, or how does it work?
Yeah, so that's under license from SPP Zona, which is the German company we collaborated on that with. They own the license for that, and the Chinese are doing that under license.
I think another question was, what are the biggest engineering challenges that still need to be solved? If there's anything we didn't speak about, first Craig, and then maybe Willem can comment.
So, Friek, solar thermal is very much an area of research which looks at improving the technology and making it cheaper. But it's not really an engineering challenge. The challenge is actually deployment. We need companies to start taking this up in South Africa and actually using the technology.
Yeah, while you're now talking, some other things sparked my mind on these green ammonia projects that I've been looking at and that OTC has been involved in. The actual availability of or the power to keep the ammonia plant going, because of the variability you get in bad places. I've seen usage of like 25% of the plant, and on other places 50, and I think the best one I've seen is 75%. So there's a lot of capital also in that side that's not used. That constant supply can make a big difference.
Very much so.
So, it comes back to, I think, and Yuri, you can rephrase my question a little bit, but if you really look at the green ammonia plant, for instance, solar power should win CSP, if I put it like that, should win hands down if it's properly done.
No, definitely for a plant the size that you typically need to feed an ammonia plant, CSP would be the ideal choice.
But
I mean,
I don't know about anyone doing that.
That's the problem.
Yeah,
That's why I say it's the stepchild.
yeah,
Because the people seem to focus on batteries only when it comes to storing energy. They're not considering thermal storage, and definitely not things like lifted weight storage or things like that.
And our work and our discussions around the gas cliff in previous webinars, we were looking at what can industrial users do. Now, if we take that, about 180 petajoule of gas comes from Mozambique, 120 goes to Sasol, 60 petajoule is basically for industrial use, of which the majority is just for heating. And that's, renewable energy should be ideal for heating.
Yeah.
Yeah, and that study that I referred to, Freek, solar thermal, those small parabolic troughs are not far off the cost of the gas already. So that's current, what I consider cheap gas from Mozambique. So that's not comparing it against LPG or LNG alternatives that will be significantly more expensive. So solar thermal certainly for industries who have the land space to put up solar thermal systems, I would think would be certainly worthwhile at least investigating.
I think a last question for you, Willem. This whole metal melting thing is quite interesting, but there are also other things. There is the whole story about cracking methane in a reformer, to make hydrogen and carbon, and also various other sort of things you can do with concentrated solar power. Are you looking at other things over and above the metal use?
Yes, absolutely. There are many other applications. You can look at distillation, the industry there, manufacturing. There are many examples, and yes, certainly we are looking into them. I think the advantage of having a small scale or a nanoscale setup that we are using is quick deployment, which is one of the engineering challenges that have been mentioned. And I think we are overcoming that by having a smaller setup, which means we can test it quicker, and we can develop the technology quicker. However, small scale or nanoscale will have its limits. But the advantage, like I said, is that it can develop quicker.
Yeah, and if you can do it in a modular fashion where you just can roll it out,
yes,
you can really speed it up. Huh?
Yes.